wave, any wave, the waves are of the two types. First one, it's a mechanical waves and non-mechanical waves. Mechanical waves and non-mechanical waves. So these needs material medium. దీనికి మీడియంతో సంబంధం లేదు, doesn't need any medium, does not need any medium. So ఇందులో మళ్ళీ మెకానికల్ దగ్గరికి వచ్చేటప్పటికి in the mechanical waves there will be the transverse waves and longitudinal waves. Transverse waves and longitudinal waves. So equations allow style or transverse wave, longitudinal waves, general equations. You can write it as n for the transverse waves, y is equal to a sine of omega t plus or minus kx plus or minus phi. So this is a very beautiful equation. ఏంటంటే దీనిలో స్పెషాలిటీ అంటే మనకి ఇది ఒక వేవ్ లో మనం స్టడీ చేస్తున్న పార్టికల్ ఎక్కడుంది, ఆ పార్టికల్ యొక్క డిస్ప్లేస్మెంట్ ఎంత y, ఆ పార్టికల్ వెళ్ళగలిగే మాక్సిమం డిస్ప్లేస్మెంట్ ఎంత a, అండ్ ఈ పార్టికల్ ఎన్నిసార్లు పైకి కిందకి అంటే వాసిలేట్ అవుతోంది అని చెప్పే వాల్యూ ఒమేగా. ఈ పార్టికల్ ఆరిజిన్ దగ్గర నుంచి లాంబ్డా టైమ్స్ లో క్యాలిక్యులేట్ చేస్తే how much distance in terms of lambda is it? This is your x and phi is called as your initial phase. Okay now, so equations కి సంబంధించిన అన్నిటికీ ఉంటాయి. This equation is a transverse wave equation. ఎందుకు? Displacement and propagation are perpendicular to each other. That is displacement and propagation are perpendicular. Okay, now longitudinal waves దగ్గరికి వస్తే ఈ రెండు సేమ్ ఉంటాయి నాన్న, y and x ఉండదు, y because longitudinal లో ఎలా ఉంటుంది, the vibration will be in the direction of propagation కదా. So both of them will be in the same sort of a fashion for you. So రెండు ఒకేలాగా ఉండడానికి ఛాన్సెస్ ఎక్కువగా ఉంటాయి. This is your basic thing. And next ఇందులో మనకి కావాల్సిన ఇంపార్టెంట్ ఫార్ములాస్ ఏంటి? relation between phase difference and path difference. So ఇది ఈ రెండిటికి రిలేషన్ ఎలా ఉంటుంది అంటే డెల్టా phi, phase difference is equal to 2 pi by lambda into delta x, where delta x is called as your path difference. That is difference in the path traveled by the waves. This is called as an phase difference. So ఇది జనరల్ రిలేషన్. లేదు ఫేజ్ డిఫరెన్స్ కి టైం డిఫరెన్స్ కి రిలేషన్ కావాలి అంటే 2 pi by t into delta t. So this is anyway phase difference, this is your time difference. Okay, so now based upon this particular thing, there are that means we can able to find out the primary equations and all these things, secondary equations, anything like that. And apart from that one, we can also find the energies, intensities and all these things. These are your wave equation. Similarly, velocity equation, differentiation kadandi adi. So that is v is equal to a omega into cos of omega t plus or minus kx plus or minus 5. దీన్ని మళ్ళీ డిఫరెన్షియేట్ చేస్తే మీకు వచ్చేది యాక్సిలరేషన్ ఆఫ్ ద పార్టికల్ a is equal to minus a into omega square sin of omega t plus or minus kx plus or minus 5. Okay, na? So this is equal to the equate chechu dini minus omega square into displacement y. So these type of the question idi. నెక్స్ట్ ఇందులోనే మీకు ఇంక వేరే ఫార్ములాస్ ఏమేమి ఉంటాయి అన్న రిలేషన్ కాకుండా ఎనర్జీ అనుకోండి, వేవ్ వెలాసిటీ ఆర్ ఎనీథింగ్. సో వేవ్ వెలాసిటీ అయితే wave velocity can be written as an v is equal to frequency into lambda. Omega is equal to 2 pi f, that's okay. K is equal to 2 pi by t, okay. ఇవి రెండు రిలేషన్స్ తీసుకుంటాం. And from this one v can also be written as an omega by k. This is called as an wave velocity. Okay, now where the particle velocity will be different. Particle velocity. Okay, na? So what is this particle velocity? Ante SHM formulas. V is equal to a omega. Okay, so this is your first thing is that is the maximum you can go for it. There is a particle velocity at that particular instant here. So from this one, okay, wave velocity also we got. Next one, energy of the part, energy density kavalante ela vastundana? Energy density or energy is equal to E is equal. So what is the value of this energy, sir? That is half m omega square a square. M can be written as an half into area into length into omega square into a square. So from this one, energy per unit volume is equal. Area and length you can take it out of there, please. That is these two things. So correspondingly change them and you can able to find out that particular thing. Energy density, energy by volume. Okay, now that is called as your generally the energy density and chippan. Okay, now energy formula aithe idi maximum energy outundi. This energy is maximum energy. So ఇంకా ఇందులో ఏముంటాయండి? ఇంటెన్సిటీ. సరే, ఇక్కడ ఒమేగా స్క్వేర్ ని 2 pi f లో రాసి సాల్వ్ చేసినా సరే విల్ బి గెటింగ్ ద సేమ్ థింగ్. The answer will be the 2 pi square rho a square. Okay, now that is 2 pi square rho a square into n square. Where intensity formula ఏంటి సార్? Intensity is equal to energy by area into time. Energy ఎంత వచ్చింది మనకి ఇక్కడ? ఇదే కదా. That is 2 pi square rho a square m square by volume or anything energy density area into thickness రాసుకున్నాం కదా. Area into thickness. Okay, now that is the time or anything you can go for that one. Intensity is equal to area into time తీసుకోండి ఇక్కడ. సో అలాంటప్పుడు సబ్స్టిట్యూట్ చేసుకుంటే ఎంత వస్తుంది? సో పైన ఏ స్క్వేర్ ఉంది మన దగ్గర. So if I multiply and divide that particular thing correspondingly, I can say that the average intensity in this case will be the half rho a square omega square into velocity, where v represents the velocity. So these are the things that you can able to obtain in this particular case, whether it's a reflection or a refraction phenomenon. So refraction jarigina, jarigina sir. Now superposition of the waves lo ennunnai. There are the different types with the different types here. So waves are being superimposed one on the other. ఒక wave ఇంకో wave తో యాడ్ చేస్తున్నారు. So displacement of the wave. Displacement of wave. So అంటే waves total distance ఏదైతే travel చేస్తుందో is equal to, that is y is equal to displacements of individual waves y1 plus y2 plus so on like this. This is your principle of superposition అని అంటుంది. So according to the principle of superposition, you can handle this particular thing. This is your displacement of any particular wave. So in superposition, you have got a three types. One is an interference. Second one, interference తర్వాత ఇంకా దీనిలోంచి ఏ ఉంటాయి ఇదే ప్రిన్సిపల్ beats. Third one. So what will be the third one here? Stationary waves. Stationary waves. So these are the things. So these are the three types of superposition of the waves. For the interference, two waves travel in same direction. Same direction with slight difference in phase. With difference in the phase, but frequency has to be constant. Frequency should be constant, or else. So ఇవి బేసిక్ గా మనకి బీట్స్ ఇవన్నీ నెక్స్ట్ వస్తాయి నాన్న. ఇంటర్ఫరెన్స్ ఫార్ములాలో మనకి మేజర్ గా వాడేది ఏంటి అంటే ఇంటెన్సిటీ ఫార్ములాస్. దట్ ఈస్ I maximum by I minimum is equal to root over this is I1 plus root I2 whole square by this will be the root I1 minus root I2 whole square. So now you need to solve these type of the questions will be here, or it is also equal to your amplitudes A1 plus A2 whole square by A1 minus A2 whole square. So sorry, this is these so this situation you can replace one in the place of the other, depend upon the values they provide in the question, please. Okay, fine. Next, if I go for the interference, what is this interference? So that is then two waves traveling in the same direction with slight difference in the phase, then intensity becomes changing alternatively. I is equal to 4 I naught into this will be the cos square of 5 by 2. So cos square of 5 by 2 ante. So depend upon the shape of that particular thing, you can able to decide here the intensity. Okay. On the basic wave equation, you can write it as on the basic wave equation or the mean phase equation. What can be the case, Nana? Okay. Sorry. So this is your, so phase difference is going to be the change. This is the basic wave equation. Apart from this one, I have also written your intensities maximum or intensity at any particular instant is equal to root over I1 square plus I2 square plus 2 I1 I2. So for this is your formula for the interference. So interference, this will be the maximum at when pi is equal to 0 comma 2 pi comma 4 pi, even multiples of the pi. For the minimum condition, you will be getting pi is equal to 3, or from the 1 comma 3 comma 5 ve kada. Okay, no. So that is odd. The even multiples aithe the odd multiples also. Okay, so these are the things, please. So this is your equation where it's going to be deciding where at which point intensity should be how much. ఎక్కడ intensity ఎలా ఉంది అని చెప్పి this will be deciding the things. Fine. So this is your interference pattern conditions. Interference pattern and the stationary waves. What are these stationary waves? Two waves traveling in the same direction. Okay, now superimpose on each other. Stationary waves where they are going to be like this. They are going to be remain fixed between the 2 points A and B. Okay, now ila fix ayi untundi and the distance between these 2 points is lambda by 2 and these 2 points are called as your nodes. These 2 points are called as the nodes and the center one, this point is called as your antinode. This is called as an antinode. So from this one, frequency is equal to, or velocity, whatever is going to be, V is equal to, frequency is equal to velocity by lambda or 2L. So V by 2L, so this is the frequency of the situations. And this is your fundamental frequency also. Okay, so in the stationary waves, the nodes will be in the formation of, that is 1:2. Alternatively, you will be getting the nodes and all these things, please. And what are these nodes? Nodes are the locations where the displacement is zero. Displacement is zero అయినప్పుడు node this is అక్కడ zero. అదే antinode దగ్గర at the antinode it will be the 2A నే కదా, this is going to be the A. That is 2A అవుతుంది. సగానికి ఇది అవుతుంది A will become, this is the case. Antinodes దగ్గరకు వచ్చేటప్పటికి maximum displacement. Maximum displacements. So as the number of loops increases, frequency increases, number of loops will also increase, and frequency decreases, number of loops can be decreased at that particular instant. Okay, so there will be the different situations, and then that is Doppler effectual conditions or whatever may be the conditions here. So depend upon those fixed situations or conditions, you have to derive the relations, please. Okay, so what are the different types of the assistance or whatever is going to be the నేను రాసింది పొటెన్షియల్ ఎంత? ఓకే, సో స్టేషనరీ వేవ్స్ దగ్గరికి వెళ్తున్నాం. ఇలాగా యూఆర్ ఫార్మింగ్ అండ్ ఇలాంటి వేవ్స్ అన్ని కూడా ఈ విధంగా ఫామ్ అవుతాయి. క్రస్ట్, ట్రఫ్, అన్ని నోట్స్, యాంటీ నోట్స్ ఈ విధంగా ఫామ్ అవ్వడానికి ఛాన్స్ అవుతుంది. ఇలా 3 లూప్స్ ఫామ్ అయినాయి అనుకోండి అదే లెంగ్త్ కి. సో దీన్ని ఎలా రాసుకోవచ్చు ఇప్పుడు? 2L is equal to lambda అనే కదా మీనింగ్ ఇక్కడ. సో కాకపోతే 3 లూప్స్ అవుతున్నాయి. టోటల్ లెంగ్త్ ఈస్ డివైడింగ్ ఇంటూ ద 3 ఈక్వల్ పార్ట్స్. That is L by 3 is equal to node ki distance. Okay, na, so total length lo each one is going to be the L by 3 and the total length is going to be of 4. Okay, na, so దీన్ని బేస్ చేసుకొని fundamental frequency అవి derive చేశారు. So what is fundamental frequency? Fundamental frequency. So this fundamental frequency F is equal to 1 by 2L into root over T by mu. Right, sir? So from this one, according to laws of transverse, frequency is inversely proportional to the F, directly proportional to the square root of tension, and inversely proportional to the linear density mu, where mu is called as what, sir? Linear mass density. Okay, the linear mass density. These are the very important factors for the forming in a stationary wave, and these laws are called as an laws of transverse wave and చెప్పి కూడా అనొచ్చు.